All right, in this presentation, I'm going to go through a solved lab example from the density lab. So first, let's talk a bit about volume, since that's really what we're dealing with here. As a reminder, volume is how much space an object takes up, and we usually measure that in the lab in milliliters, and I'll abbreviate that as this ml, lowercase m, capital L here. One of the easiest ways that we can measure the volume of an object that has an odd shape is through a technique called water displacement. And I showed an image of that here. Basically what it is we will fill a graduated cylinder, measure the amount of water, drop an object in, and see how much the water rose. And I'll go through that on the next slide. So this method, really the steps are, first, fill the graduated cylinder with an initial amount of water. You can see in the image it looks like it's around 150 milliliters here. We're going to actually measure that initial volume of water, and we should really record that as well. So again, in this image here, it looks like I have 150 milliliters to start. We then take our object and we place it in the water. Now we expect the water to rise by whatever the volume of this object is. We then measure the final volume of the water. So we knew the initial measure was around 150 here. Just kind of eyeballing it, it looks like the final measure is around 180 milliliters. So it rose from 150 to 180. Now to find the volume of the object, that is equal to the final volume of water minus the initial volume of water. In other words, it's how much the water rose. Now let's go through an example problem. Let's say that I fill in a graduated cylinder with 45.3 milliliters of water. That's my initial volume. I then place an object in the water and the level rises to 67.9 milliliters. In this example, I just want to know what is the volume of the object, not the water, but the object. Well, I know that the volume of my object is equal to the final volume of water minus the initial volume of water. In other words, how much the water rose. If I plug in my amounts, 67.9 milliliters for the final volume of water minus 45.3 milliliters for the initial volume of water, we can see this is just simple subtraction. Now, I should point out the larger amount is always going to be first. And the reason is we expect the water to rise from 45.3 to 67.9 milliliters. After we do our subtraction, we can say that our object takes up 22.6 milliliters of space. That's its volume. And that's how much the water rose. But what about density? This whole unit has been focused on density. Well, if we know the mass of the object, we can calculate its density. Remember, density equals mass divided by volume. We just talked about how to calculate volume, how much the water rose. So if we have a mass, we can do the mass divided by that volume to get our density of our object. Let's go through an example problem. I'm saying that I fill up a graduated cylinder with 21.9 milliliters of water. I then place an object which weighs 13.2 grams in the water, and the level rises to 80.0 milliliters. And the question is asking, what is the density of the object? Well, right away, I can see that my mass is 13.2 grams. That's how much it weighs. But I don't know the volume of my object yet. So let's use our technique through water displacement to find the volume of the object. As before, the volume of object is the final volume of water minus the initial volume. For final volume of water, that's what it rose to, 80.0 milliliters, and the initial volume is 21.9 milliliters, where it started. I will plug those values into my equation and subtract to find that my object is 58.1 milliliters, and that's the volume, not the density, because we only calculated the volume so far. So let's take that 58.1 milliliters, the volume, and use it. Remember that density equals mass divided by volume. So for my mass, I'll plug in how much the object weighs, 13.2 grams, And for the volume, I'll plug in what we just calculated, 58.1 milliliters, the mass divided by the volume, and after I do that division, I'll find that my object's density is 0.227, and then the units of density here, grams per milliliter. So that's how we would find the density of the object. We would first calculate volume through the water displacement method, and then we would do mass divided by volume. All right, I hope this helps you understand how to complete this lab and how to use the water displacement method to calculate density.